first challenge problem where we're looking at this first idea of what it means for to describe a reaction rate. Navigate to the correct place here. Zoom in so it's not tiny. All right, so in this we can describe the rate of reaction, this reaction found here, as being 4.3 times 10 to the -3 molar per second. So we are seeing a change in this reaction under a certain concentration per unit time, right? So that's the first thing that we're going to talk about here, is that when we describe these rates, right, it's always going to be depending on some amount. Typically, we'll either talk about concentrations or sometimes in terms of numbers of molecules per unit time, right? And this here is the overall rate. So this reaction is occurring at 4.3 times 10 to the -3 molar per second, right? It doesn't necessarily relate to any specific species, right? So we can talk about this as being 4.3 times 10 to the -3 molar per second for the reaction. Right? In the problem here, we're asked to talk about how quickly something disappears or individual components of the reaction. Right? So we can say in general, let's write actual like human being. In general, we can describe this rate as being equal to how fast A changes, right? The change in concentration of A, and we've probably seen this before. Here it goes. Where we talk about a concentration as using brackets, right? So the change in concentration per change in time, we can relate that to the way that the change in the concentration of B is changing in unit time. And we can relate that to the change in concentration of C per change in time. Right? And we can change that in terms of concentration of G per unit time. And finally, F per change in time. Right? So this rate we can then describe for each one of these. Right? And in general, what we're going to see is that we can talk about all of these here, all of the reactants, because their change in concentration is going down, right? That when we calculate this change here, right, that change is going to be a negative number, right? And in these rates, we don't talk about a negative rate, right? It's like when we reverse, we don't talk about going backwards at a negative speed, right? When we reverse, we still can clock our speed, and our speedometer will tell us how fast we're going in a positive number, right? Because of that, each one of these reactants should have a negative in front of it, right? To account for the fact that the change that's occurring, this final minus initial, is in fact negative. Does that make sense? And we can describe this rate stoichiometrically, right? So if we look at C, for example, it's going to be a 1-to-1. So this would be, there's a delay. For every one of those because there's a 1-to-1 ratio between the reaction, for every one reaction that occurs, we get one C molecule to react, that would be that this rate that we described is equal to the negative change in concentration of C over the change in time. If we look at A then, for every 1 time the reaction occurs, we get 2 moles of A that changes. So this would be a 1/2 in front. Same thing with the B. So we can describe this rate then as being any one of these values. Right? If we continue over here, now this is the change is going to be a positive number, so the change is still going to be it's going to be a plus, but this is going to be a 1/3. This would be a plus, and it would be a 1/4. Right? So that rate we've described or been given, the rate of the reaction is going to be equal to sum of this because of values. Right? So if we define this one as A, right, the value of A is going to be the rate of this reaction is going to be equal to a negative 1/2 the change in concentration of B over the change in time, right? Or we can say this would be the rate of B, right? Then the rate of B is going to be equal to this value for our rate, the 4.3 times 10 to the negative 3 molar per second times 2. Which means that this would be, what, 8.6 times 10 to the negative 3 molar per second is the rate that B is changing. And it would be, again, we wouldn't worry about the sign. The sign just means that that is disappearing, right? So the rate, the B is disappearing at that rate. So what would be the rate of appearance for F then? Call this B. What is going to be the rate of appearance for F? Right? Well, we're still going to do this. Rate is equal to now 1/4 change in concentration of F per change in time, which we would call this rate F. So rate F is going to be equal to the rate, 4.3 times 10 to the negative 3 molar per second times 4, which is going to be 13.2, 1.32 times 10 to the negative 2 molar per second is the change, the rate of appearance of F. I did that number in my head. Is that correct? It's 4.3 times 10 to the negative 3 times 4, 1.32 times 10 to the negative 2.
1.72.
1.72?
Yeah.
Did I screw that up? 12. Okay. All right. It didn't change on yours. There's a delay on my screen. All right. Questions on that? Let's go back and look at one more thing before we stop. I just want to make sure that everything's synced. Are you guys seeing the shared screen, or are you not?
No.
H. Let's try this one more time. Apparently, you're not going to work today. All right, so we'll just stop there. So we can also describe the different, which is what I was hoping to do. Apparently, my iPad has stopped communicating. So we will stop there and go back to or start breaking into our